We already mentioned the core benefits of reducing SLCPs. Let's look at a little bit more details with some spatial granularities. Okay, so the relation between SLCPs and sea level rise is shown here. Top 10 cities are at risk of coastal flooding damage by population vulnerability based upon projected 1 meter sea level rise by 2070. So Miami, basically a tropical country with very high warming in the Gulf of Mexico and generally the North Atlantic, with accelerating sea level rise along some parts of the east coast here. Mumbai, very crowded city on an island that is facing increasing sea level rise problems, and there are also changes in cyclones that seem to be threatening this region, even though it's not clear yet whether it's part of the low frequency natural variability or a trend. Kolkata, another highly crowded place. Dhaka, Bangladesh in general is sitting at very low sea level, with the highest land being just about 1 meter above sea level, and Bay of Bengal is definitely having cyclone issues. So even a few centimeters of sea level rise is going to bring you much more inundation and storm surge. Haiphong, Shanghai, Guangzhou, Ho Chi Minh City, Bangkok, Rangoon, and so on. And you can see the projections here going from 2000 onwards. So this is the annual rate of sea level rise. Business as usual reference is going to bring us almost 2 meters by 2100 here. And CO2 only, black carbon plus methane for plus HFCs is going to bring us down to 1.5 meters, which is still not a good scene. Full mitigation of CO2 SLs, so if you add carbon dioxide as well to the short-lived climate pollutants, then you're going to get down to about 1 meter and so on. So there is the 2 degrees centigrade, 1.5 degrees centigrade global mean targets, and then we have to worry about what it translates to in terms of local warming and the impacts of warming on cyclones and local sea level rise, etc. Plus human actions like living closer and closer to the coast, destroying natural defenses like mangroves, coral reefs, wetlands, salt marshes, etc. Okay? This is cumulative sea level rise since 1900. So you can see that here we are talking about already being here we are at about in 2020 I think we are at global cumulative sea level rise of almost 30 to 40 centimeters, and we are going to end up in the range of 120 or so sea level rise cumulatively as well. Okay, effects on public health. Air pollution, a preventable risk. SLCPs, particularly ozone and black carbon and co-pollutants, which are important parts of the PM 2.5, the particulate matter of 2.5 micrometers air pollution, are harmful to human health globally. PM 2.5 is the leading environmental cause for poor health and premature death. Okay, here are some numbers. Premature deaths in year 2010 globally. Air pollution is responsible for 3,500,000 from indoor PM 2.5 pollution. Indoor cooking is a huge problem still in Asian, African, and South American countries. 3,200,000 from outdoor PM 2.5 and 150,000 from ozone pollution. This is just for year 2010. Okay, so approximate share of premature deaths from air pollution. Huge numbers here in Southwest and Central Asia, Northeast and Southeast Asia, and the Pacific 45%, and here in North America and Europe 10%, Latin America and the Caribbean 2%, good news, and Africa is 9%. So this is the climate justice disparity parts, but of course countries like China and India have their own responsibilities, and they are working on them as well, right? Air pollution is a huge problem in many cities in Asia and in general China and India. Disease due to PM 2.5 and ozone include heart attacks, strokes, heart disease, congestive heart failure, lung cancer, and so on and so forth. So you can imagine that globally air pollution is the second leading risk factor for global burden of disease in 2010, behind high blood pressure and together with tobacco smoking, including secondhand smoke. Air pollution is now blamed for everything from acute chronic obstructive pulmonary diseases, blood pressure, strokes, mental health, diabetes, and so on and so forth. Effects on agriculture. Crop losses due to ozone pollution for wheat, rice, maize, and soybean, 110 million. So that's more than a billion ton there. The SLCP effects on plants due to ozone and black carbon and pollutants include these things: impeded photosynthesis, reduced ability to sequester carbon, which is bad, plant cell damage, reduced crop production, reduced quality and nutrient value of food and feed. So the absorption, micronutrients, and so on gets affected as well. Increased leaf temperature with uncertain effects, reduced sunlight reaching plants affecting photosynthesis, so the solar dimming is a serious problem, and approximate share of global crop losses also are distributed this way, with the huge impact in North America and Europe. So there is the distribution is different than the health impacts. Okay, the benefits for public health by reducing SLCPs would save millions of lives per year. So we've talked about the various sectors: residential, industry, transport, agriculture, fuel, and waste management for black carbon and methane. So again, you can see health benefits would include global implementation of SLCP measures, saving 2,400,000 with a range of 0.7 to 4.6 million deaths avoided annually from reduced PM 2.5 outdoor air pollution by 2030. Okay, so there are additional health benefits from reduced PM 2.5 indoor and ozone air pollution, of course. Okay, so these are the various measures, and these are the outcomes or health co-benefits we would get out of that. So those are solid enough motivations as to why we should immediately set on reducing SLCPs at source and other technologies to reduce them. Okay.